Before starting Project 5, verify that your CentOS boots properly after doing Project 4-4, and then shut it down and remove the snapshot. If you have trouble with snapshots, you may need to upgrade your Oracle VirtualBox to the latest version. We currently have installed 5.00 on a few machines here on campus, and they've exhibited strange behavior with that version. We have since upgraded to 5.04, and Snapshot seems to be working better. With the snapshot deleted, create a new snapshot as it states for the beginning of Project 5-5. And then start your virtual machine. Once your machine starts, go ahead and switch to the TTY2 and log in as root. In this, we're going to use the parted command instead of fdisk. Fdisk is used for the MBR style partitioning, meaning drives less than 2 terabytes in size. Parted can handle both MBR and the new GPT partitioning style for drives over 2 terabytes. So to get practice with the new command, which will become more useful as the years roll on and disk sizes continue to be over 2 terabytes in size and larger, we use parted /dev/SDA. Here it says instead of getting help with the M command, we actually type the word help. So this goes above my screen. I can use my shift key and page up to view the help options towards the top. If you note, we can do mkpart for making partitions. We can type print to view the partition table. Quit to exit the program. You also have RM and the number. If you accidentally create a partition that is the wrong size, you can use RM space the partition number to delete it. At this point, they want us to print the partition table. So type print. The output looks a little more friendly than fdisk. We see partition table in gigabytes and megabytes instead of on sector boundaries. Then wants us to record down the 36.7 gigabyte, the ending of our partition, our logical drive, and then it wants to record down the ending of the extended. So any space between 36.7 and 64.4 is unpartitioned, unformatted, or you could say unused space. We want to use that unused space to create a second logical drive. So now we're going to make the partition mkpart. We hit enter. It asks primary or logical. We have no space left to create a primary, so we have to type logical. File system type ext2. It says go with that as the default. Hit enter. The start, that is going to be the 36.7 GB. You have to put the GB. If you don't, it may try to read that as megabytes and create a wrong partition size. You then may have to use the RM command to delete the partition if you did that incorrectly. The ending partition, 64.4 GB. Hit enter. Now I'll type print to view my creation. Here I have partition 6. It shows it starts at 36.7 gig and goes all the way to the end of the extended 64.4 gigabytes. or total size of 27.7. Yours should look very similar to mine. Once everything is correct, I will type quit and exit the program. I'll use part probe to make sure that the kernel recognizes the new partition that was just created. Now I'm going to type pv create. We're dealing with logical volumes. Some server systems have databases that are petabytes in size. There's no way that you can buy a petabyte hard drive at this time. So what people have to do is link many hard drives together to create one large space so that you can store large databases. So this pv create is going to mark the partition /dev/sta6 as a partition to be managed by logical volumes. Now, I could do pv create, and if this was a large system, I would have more than just dev sta6. I would have 4, 5, 6, or 7 or more unused partitions that I would want to link together into one large pool. So this one is 27 gig in size. If I needed to create several terabytes, I would have to link several empty partitions from multiple disks together, and then it creates one large pool. So this right here just marks that as to be managed by logical volumes. The next command, vg create, this one is actually pooling the free space together under a single name. So a volume group. This is what it says, grouping of several volumes or partitions. In this lab, we're only linking one partition to it, but we could space and add other partitions if we had them. It may be like on a second disk, like SDB and so forth. So here we're going to just group the single one that we have. At later points in time, you can add other empty storage volumes to this volume group, and that'll allow you to expand logical volumes in the future. The ability to grow volumes is the benefit of logical volume. You can't do that with a physical disk. You can't go buy a 1 terabyte disk and then later automatically make it a 2 terabyte disk. So logical volumes, though, you can buy a second drive and add its capacity into the current volume group and then expand the logical volumes. So this LV create is going to use the pool of information, the pool of devices created with the VG create, and create a logical disk that we can format. So LV create 2 gigabytes, give it a name of volume 1 and VG00. Again, these names, VG00 was just made up by the author. The same thing, volume 1 is a name made up by the author. You could use anything in those spaces. Now we create a second volume. I'm going to use my up arrow key and change volume 1 to volume 2 and change this 2 gig to 2.5 gigabytes. Now again, this is just for practice. If it was a main server, you might have 4 5 terabyte drives linked together into a large volume group for a total space of 20 terabytes. And then you might have a logical volume of, say, 15 terabytes for your database, and then the other 5 terabytes could be spread across, say, the home folder, the root folder, and different partitions that you would need. Now we need to format these volumes with the ext4 file system. For the second one, I just hit my up arrow and change volume 1 to volume 2. Hit enter. Both are formatted. Now to make folders for them to mount to. Make directory, volume 1, hit my up arrow key, change the 1 to a 2, hit enter. Now both folders have been created. I'm going to skip a couple of steps and go straight to editing the FS tab. You should do all of the steps in the lab. We're trying to make this video a little bit shorter. So editing this file, I go all the way to the end of the last line, arrowing down, hitting end on my keyboard to get to the very end of the last zero, hit enter, and now I'll put the DEV VG00 volume 1 tab, because this is a, remember, FS tab, all values have a tab between them. Mounting it to the volume 1 folder. File system, ext4. Defaults, 0 space 0. Now I can retype the line. I can also hit the escape on the keyboard, type Y twice on the keyboard, and then hit P to paste. So Y is for yank. If you hit it twice, it copies stuff into the buffer, and then P will paste a line. I'm now going to hit insert and go over and change this 1 to a 2, and this other 1 to a 2 under volume. So verify it looks, these bottom 2 lines look the same as the graphic bottom 2 lines. I'll hit escape, type :WQ, I'll hit enter, and at this point in time you should probably reboot your system to verify everything works. I'm going to type mount-A and then df-h, lowercase h, to verify everything is mounted. df-h command is a little bit cleaner than typing mount and viewing all of your items. So I see that I have my 2 GB volume 1 and my 2.5, or here it's slightly less than 2.5, so it's showing 2.4 GB volume 2. Your screenshot should show the 2 volume groups. If you reboot the system, they may not be at the very bottom of the line. They'll probably be up about 3 or 4 lines in the middle. So that's okay, just as long as you see the VG00 volume 1 on the screen. Then you take the screenshot and submit. So go ahead and do number 20. Look at all of the outputs for volume groups. And then once you're finished, power off the virtual machine and delete the snapshot, as long as everything is working. That'll merge all changes into the virtual machine.